Alright, this is gonna be, I don't even know what day, I think day 5 of the code. Studio, count unguarded cells in the grid. You're given two integers m and n, representing 0 index m by the grid. So given 2D integer arrays, guards, and walls, where guards is equal to a row and a column. Okay, makes sense. So this is just coordinates of the walls, coordinates of the guards, and actual grid dimensions. A guard can see every cell in the four cardinal directions, unless there's a guard or a wall obstructing it. A cell is guarded if there's at least one guard that can see it. Okay, makes sense. Return the numbers of unoccupied cells that are not guarded. Okay. We're just returning the number. Guess my first thought right here is just to simulate what would actually happen. I mean, if you have a guard, you would just go in every direction, whether that's like with the DFS or BFS, and mark those cells as guarded. And then you would just return like the area minus the guarded cells minus the number of walls minus the number of guards. That's what I'm thinking. And the total area of the grid can be up to 10 to the 5th, which means that O of n solution will work. So I guess my intuition right now is to try to start at every guard and simply search up until you reach another guard or hit a wall or hit the end of your search space, which is going to be going out of bounds of the input array or input matrix. So for each guard, try to mark guarded cells in each guard direction. This comes with a little catch though. You only want to mark it until you hit another guard because it will continue off in the cardinal direction that you were going to do anyway. So it's really no point to continue at that point. Or you hit a wall. Or you go out of bounds. So now I'm trying to find out a good way to do this. All the checks are going to be pretty easy. So I'm thinking of just literally doing it for each card. I'm thinking of defining a helper function for each card of I, which will mutate the matrix. That's what I'm thinking of doing. And then we're just going to run this helper for every guard. And we're just returning the count here, which means that we should keep a running count of guarded cells that we uncover. All right. So that makes sense. Let's just try to start by creating our matrix. So what would that be? That would be an empty matrix to begin with, and it's n the number of columns. Yeah, so for I in range, the rows, we're gonna add a new matrix times with each row being a matrix of the number of columns. Let's print this first. That looks about right to me. So a 0 can represent an empty cell, and a 1 can represent a guarded cell. Let's just make a note of that. All right. And then we could define a helper function now, which will take the start and end position of the guards. And in each one, we do want to check if there's a guard there already. So I think there's two ways to go about it. We could make these sets and do lookups, or we can just store them in our matrix. I think that would be the better approach, to just store them in the matrix. I think I can do this. Just make sure that I'm not tweaking. All right, we can do that. Well, let's say a guard is a 1 and a wall is like a 2. And we'll do the same thing for the walls here. Let's say 0 is unguarded, -1 is guarded. Then 1 is guard, 2 is wall. Alright. And then now we could do a helper for each guard with a row and column of each guard. And we're going to start by trying to do the north side. I'm thinking of trying to do this with a DFS and like just take a delta of the direction, which is dr/dc. Would this work? Well, what's our base case is we would just want to exit this DFS immediately if we're out of bounds, or we hit a wall, or we hit a guard. So if matrix are, if this is equal to a guard, or this is equal to a wall, or if it's out of bounds, so if r is less than 0, or a column is less than 0, or row is greater than matrix length of the matrix, or this would be greater than or equal to, or the column is greater than or equal to the length of the matrix's columns. We're going to return immediately. If not, then this cell is surely either unguarded or it's already guarded, but we can keep going. Is equal to -1 because we're saying that this is guarded now. And then we're going to call mark guarded recursively with now r plus dr, c plus dc, and dr dc. So this should attempt to mark the cells as guarded up until you hit base case. I do want to print the matrix first though, just to see what it looks like. And just make sure this is exactly what we expected. And so far, I think that we're good. So for G and guards, we're going to try each one of the directions as well. So what are my cardinal directions here? That would be north, south, east, west. 0, -1, -0, and -1, -0. These are all of our dr/dc combinations that we're going to be trying. And then we're going to mark guarded starting at the position of the current guard that we're on. So this OG, we don't want to start it exactly at this though, because if we do, this is going to immediately return because the current cell that we're on is guarded. So we should actually iterate through the directions for D and dir. DRDC is going to be equal to D. So we're going to like deconstruct that. What are we going to mark guarded now? We're going to try to go in that direction just by one square. And then we're just going to print our array, our matrix. I want to ensure this doesn't infinite loop or something. Did I spell this wrong? Mark guarded. Okay. Hopefully no infinite loop or something like that. -1. Yeah, so these and then the zeros are the ones that are not guarded. In this test case, I'm expecting it to be 4 zeros in the corners, which is correct. We can actually keep a running count. So if matrix are, if this is already a -1, we're not going to add the result because we don't want to double count. So I guess we'll just count if it's equal to 0. Oops, I did not mean to normal res. This is res of 0. And then we're going to return res of 0. Okay, we might have overcounted. 1, 2, 3, 4, 5, 6, 7. That one is surely right. So, why does this actually not work? I was trying to be smart. Ah, interesting. It's because you don't actually traverse it. Oh no, that's right. This is going to be the numbers of cells that is guarded. So the unguarded is equal to m times n. And then it's going to be minus the res of 0, minus the length of guards, length of walls. So that one, the logic was working correctly, but I just had it reversed where I forgot to subtract it because I was counting guarded cells, or guarded empty cells. Let's go ahead and try to make a submission. All right, this took me 16 minutes.